Hello, everyone. Really nice to be here. I've been speaking at a bunch of different droidCons. This is the first time I'm speaking here in the US. It's very exciting for me. So my name is Erik Hellman. I work as a freelance Android developer back in Sweden. So I had a long, nice flight over here this Wednesday. I'm going to talk about multi-threading, concurrency, and async on Android. It's like a very long title. And the reason I want to talk about this is basically because over the last couple of years, I've noticed that this is hard, and we keep making mistakes in this domain. So what I'm going to do is I'm going to talk a little bit about how it works and why it's hard, and then we're going to go through the stuff we have in Android to work with this. And it's very basic, it's a little bit of fundamental stuff here, and hopefully there will be some repetition for all of you and some new stuff, hopefully as well. So let's. Oh yeah. Also, I heard that Dan Liu had a puppy in his slide, so kitten. We're gonna come back to this kitten here. Remember this one. Multitasking. I'm gonna talk about multitasking first here. It's really hard in real life. How many of you drive? How many of you drive car to work? A bunch of you. How many of you text and drive ever? Yeah. You're still alive, so it must be okay, right? The thing is, like, when you drive, you're not really conscious about when you're driving. You're mostly focusing on your texting when you do that. So it kind of works because you're so used to driving, so the whole driving operation goes by autopilot. And that's how we do most of the things in our life. It actually is, you've probably seen a slide like this before, like the tip of the iceberg is your conscious part. It's a very small part of your mind. Most of the stuff you do, and it goes for everything in your life, is done by your subconscious. And we have seen this science prove this over and over again. And another way to look at this one is like this. The problem-solving part, your conscious mind, is very good. It's working up there. That's the problem-solving. That's the new stuff that you haven't encountered before that you need to figure out. So when you're driving and you're texting and suddenly there is a moose coming up on the road, I'm from Sweden, so we have a lot of those. That's when your conscious mind hopefully kicks in and will be able to start braking. But if you're focused too much on the texting, if you're doing too much things at one time, well, you'll hit a moose. Everything you're good at is controlled by your subconscious, basically. It's autopilot. This goes as well for programming. So when you get really good at writing certain type of programming, it will basically be done by your subconscious. You will just, I've done this so many times before, so I just do it like that. Your conscious mind will just be maybe fidgeting with the details a little bit, but most of the part is actually done by your subconscious. So there's been a lot of written about this one. One book that is very good explaining this one and explaining another thing that I'm gonna move on to is How We Decide by Jon Lehrer. I can recommend this one. It also talks about another aspect here. The conscious mind can keep track of about 4 to 7 pieces of information at the same time. If the amount of information you need to keep track of exceeds this, you'll start making mistakes. So I'm going to give you a very simple example, which is very good here. So have a look at this string of characters. Close your eyes and try to remember it. How are you doing? How many did you be able to remember? Okay. So what about now? Much easier, right? This is a trick we're gonna use. We're gonna come back to this one. So we're gonna see first. We're gonna move on to look a little bit under the hood. How does threads and concurrency and stuff like that? How is it implemented on Android? I'm not gonna go into super much details because that will take like the entire day. I'm also not a kernel developer, so I don't know every detail here. But you probably know that Android runs on the Linux kernel. So everyone knew that, right? Okay. So it's called multitasking here, and the reason we call it multitasking on Linux is because Linux as a kernel is not aware of processes and threads. Now, there are still processes and threads, but those are up in user space in the application layer. And the most important process in Android is the Zygote process. This is started by the system when the phone boots up, and it keeps running there. And whenever a new, and the cycle process is represented in the kernel by something called a task. So Linux kernel keeps track of tasks, whether it's processes or threads. You're going to see soon more detail about that. As soon as you want to start an app, you click on an app on your launcher, or the first app is going to be started when you boot up the phone. The system called fork. Those of you who have done native development or have done multi-process development in C or C++ probably seen this one before. Fork basically creates a copy of the current process. But this is not, the fork doesn't exist in the Linux kernel. Instead, there it's called clone, which is what it does. It clones the running task, and you get a new one, which is identical to the Zygote process at first, and then it's get initialized with all the parameters for starting your app. So how does fork work? This is a good thing to know. So if you would do fork yourself in native C++ or C, you would do something like this. You would declare a variable called new PID, of the type PID-T, and you call fork. And when this one returns, you will have two processes. You will have the old parent process, and you will have the new process. Now, the return value of the value of new PID here, it varies between the child process and the parent process. The parent process will get the value that is the process ID of the new process, but the child process will have the value 0. And this is how you detect this in your code. Now, you probably will never do this as an Android developer. There is no reason for you to call fork. So instead, you will start using threads. And, well, everyone here has probably created a thread at some time. It's really simple. You create a new thread, you probably pass it a runnable, or you override the run method. And you do your stuff there in that one. And then in order to start this one, you call start. Super simple. So how does it look underneath? Well, underneath, Linux or Android uses something called POSIX threads. It's a standard for controlling threads. So what you do is you call the method pthread_create, give it a pthread object, and a pointer to the function that's going to run on the new thread. This is equivalent to your run method. Like pthread_create and POSIX threads can do a little bit more than Java threads. You can pass parameters into that one, etc., but that's outside the scope here. So basically, it works the same way, but you pass a pointer to a function. Now, underneath in the Linux kernel, you already know that we use the clone and the clone function. The clone function is used both for threads and processes. So when you start a new thread, what you do is you configure the cloned task with a bunch of parameters. You're saying, yeah, clone this one, use the same memory space, use the same file descriptors and open file pointers, etc., and signal handling. So it will basically be a new task running in the same address space as the previous task. When you want to start a new process, all you do there is you say, here, yeah, reuse a signal child handler, and it will create a new task with a copy of the memory and everything like that from the parent. So Linux doesn't do any difference between scheduling a thread or a process. So there is no real performance gain in most cases when it comes to scheduling for running a process instead of a new thread. Good thing to know. There are other reasons why you might want to run it as an extra process, but usually for Android applications, that is never the case. So that's multi-threading and multitasking on how it's implemented in Linux. Now let's move on to the thing I'm going to talk about more here. So multi-threading, concurrency, and async. So there's like different levels of this. Multi-threading, you have that all the time, but usually you don't really have to care about it. And the typical thing here is like when you run multiple applications on your phone, which you probably do, you have a lot of them running at the same time, you don't have to care about concurrency because they run in different address spaces, they're not touching each other's resources. So from a developer's perspective, yeah, it's fine, nothing to worry about. So we would like to maintain this situation as much as possible. As long as you don't have to care about concurrency, that's a good thing, because that's when it gets tricky. So the same thing goes when you work in your own application. You can have like one worker thread, which inserts data into a database, and you can have the main thread, which, well, you shouldn't query on the main thread, but for the sake of argument here, you will read up stuff from the content provider on your main thread. Now, there is no concurrency from the developer's perspective of the app here, because it's handled by SQLite. Also very good. Now, okay, what if you need to do concurrency? And let's take a very simple and naive example. You have a shared data object, and you have a worker thread that updates that one, and you have your own main thread which will read that one. Now, this won't work very well, so you need to synchronize. And we remember from studying Java that, yeah, let's just put synchronized on all methods and everything is fine. And I would say, like, yeah, this probably, we never do this, right? And I actually run into, not this obvious example, but I've seen this happen from time to time, like, because it's an easy mistake to make. You put synchronize where you really shouldn't. Okay, and then you learn about something called immutability, like the Kotlin has that one for the value objects. It's really great, so we should do that instead. So you convert your shared object to an immutable object. Yeah, now we don't have that problem anymore, because the writing thread can't like update the instance that the reading thread will work with. Problem is, now you need to have some way of communicating from the worker thread to the main thread that an update happened. So yeah, now we need some kind of manager. Yeah, so you create that one, and it has a set of listeners that can make callbacks. So when you update the data, you just iterate through all your listeners and let whoever listening knows that, yeah, we had an update. Super good, right? What can go wrong here? Well, we're iterating through the listeners and calling them, notifying the listeners on the same thread that the worker thread is on. Which means that when you receive this in your activity, you need to make sure that you do whatever work you want to do in the main thread on the main thread. So you need to move to the main thread. So you can either do that in your like activity or fragment or whatever, or you can actually do it in your data manager here. So you use a handler which runs which uses the main thread, main looper, and then call post on a runnable, which will do the work instead. And yay, now we're done. But now it's getting complicated. This is just for sharing data between two threads. So whenever we do concurrency, we kind of end up in this situation. We'll build a huge amount of boilerplate code just to deal with this, and oops, and it will go wrong someplace. Remember, 4 to 7 bits of information. So if when you write your program, needs to jump across the code everywhere, you tend to make these mistakes. I did some research before this presentation, so I thought, like, okay, what's your most common crash? I had a guess that it would be one of these two. It's very interesting, actually. I actually thought illegal state exception would be more common. So how about here? How many have the null pointer exception as your most common crash? Say about half. The legal state exception? Okay, so it's about this thing here. But if all our code would be synchronous, procedural, we wouldn't really have a null pointer exception unless we had like some misread the documentation. It would be much, much more rare. We could just check every call we had that we didn't get a null back, etc. But since we have asynchronous calls, we need to check the value every time, and it's a little bit more tricky. So that's the async problem. And let's look at this one. This is the one who implemented this didn't know about retrofit, so yeah, bummer. So it's a network call factory. We provide a URL, and we provide a callback, and we get a callback when it's done. So what's the first problem here? Any guess?
The callback's not being triggered on the UI thread.
Thank you. Yeah, that's one thread. Another problem? Anything? Any guess? Well, let's move on and look at. Okay, let's see how we would use this one. So we would use it like this. So you're absolutely correct. We in our onCreate method we call fetch data. We give it the callback, and we take our products adapter, we call set products on it. And, well, that's not on the main thread, right? So, damn it, ouch. So you will get a probably legal state exception or whatever it is we get there. Yeah, let's fix that. Done, right? What now? What can go wrong? I press back. So that you know, whenever that happens, might be too late. Because what does it do? So run on UI thread will post something on the main looper, basically on the message queue for the main looper. It will end up in the back of that one, and whatever we did when we got the response back from the network, the user might have pressed back or something else might have happened. He might have rotated the phone or something. So yeah, that doesn't work very well. Yeah, there is a method called isDestroyed. Let's use that one instead. And suddenly things are getting more complicated again. There's one thing missing here also. Anyone have a suggestion? When we get on destroy, we would like to tell the network call that it shouldn't keep going, right? Canceling is a good thing. But yeah, so it's when we write this ourselves, when we try to do all that asynchronous implementation in our own code, tricky. So the problem, sum up, first of all, we should be thread aware. The worker thread should know that it's running on the worker thread and it should deliver a result on the main thread. Very obvious, but you know, it's easy to miss. Callbacks should go on the main thread, and it should be possible to cancel this one. Once you get on destroy in your activity or whatever lifecycle callback you want to cancel it. You don't want the result anymore. Now, can you get this problem if you have only one thread? If you're only on the main thread? Everybody's like, I don't dare to answer. So I call this a single-threaded async problem. And it's a very naive example, and the reason I took it very naive here is to simplify it, but I've seen this a couple of times, similar things. So we have a fragment, very simple fragment, and we have our method called show start page, which will put that fragment up, show that fragment. And then we have decided to show a little splash screen before this happens, and we do this. And now you will say like, oh, nobody would do that. And I would say, no, you're wrong. That would actually happen. And it's not like a single time I've seen this. I've seen similar cases of this happening everywhere because like, yeah, we'll just do something here and I delay it for a couple of milliseconds and things will be fine, right? So we wait 5 seconds before we call the show start page, before we do a fragment transaction. And during that period, the user might have pressed back or home or whatever. And this ends up in your log. So how many of you have this in your crash logs? Really? No more? Illegal state could not perform this action. Yeah, so this is specifically for the fragments, and similar things keep happening to people. So whenever we do this, remember I said that 4 to 7 pieces of information, that's our maximum. So let's say 4 rules. Let's remember these whenever we want to do something asynchronous. And you want to be able to start the job. And that would be obvious, right? But we will see one example later where the starting is not that very obvious. We want to receive the result, of course. We want to have a callback for that, which goes to the main thread. We want to be able to cancel the job, but not only cancel the job, we want to cancel result delivery because these are 2 different things. So first of all, canceling. Look at this code. It reads from the dev_urandom file on your phone. So just keep reading forever and ever with a random amount of bytes. Well, random set of bytes. And what we do is we start this thing, we wait 1 second, and we call interrupt on the thread. How many think this will abort the while loop? Of course not. So I asked that question as well. I just phrased it a little bit differently. Will input stream read be aborted when you call thread interrupt on that thread that's reading? No, it won't. But what does the interrupt method do on thread then? Well, you go to the Java documentation, the Java essay documentation and the Java tutorials, sorry. And you read that documentation, and well, calling interrupt on a thread is just an indication. It just sets a flag, nothing else. It's up to you as a developer to read that flag. So for us to be able to cancel a thread in the very simple example I had before, you need in the loop, after every read, check if you have been interrupted, and in that case, just return. So there are the methods. If a method ever throws interrupted exception, they do this inside the method, but most methods don't throw interrupted exception. So read on the input stream is one of those. So to sum up, threads can only be started once. You probably know that. It's limited support for canceling. There's no built-in support for do a callback on the main thread. Just avoid this one. There are so much better utilities in Android for using this. So everything in Android around like how threads work and stuff is basically built around the handler, the message, the looper, and the message queue classes. A message queue is super simple. It's just a linked list of messages. The message queue class has a very limited API in the public API. You will probably never use that one yourself, but it's good to know that it basically just wraps a linked list. And the way to work with that. So very simplified. I cut it out the code there. We're not going to stay on this one much, but it's basically you call next on the message queue, you will get the next message. This method will block until there is a message available. So yeah, nothing strange there. The looper, though, is much more interesting because that one you probably want to know about more, especially if you're going to do your own looper. So looper will basically loop forever with a message queue calling next on it forever and ever and ever. This is also a simplified view of it. This does a little bit more than this. Now, when you want to create a new looper, you can just call the looper and call prepare and then set up stuff and then call looper.loop inside your own thread class. There is a much better way to do this. It's called handler thread. So you call handler thread, create a new instance of that one, call start, and then when you want to create the handler, you call get looper on your handler thread, and this is how you do your own looper. Now, a message queue, looper, and handler work together like this. A looper can only have one message queue, so that's the same thing with message queue and looper. That's a one-to-one relation, obviously. But you can have multiple handlers for the same looper. That's why you can pass the looper as parameter to the handler. This means that for our main thread, for instance, it would look something like this. You will have a handler that generates like the callback events for click listeners and broadcast receivers and lifecycle events and stuff like that. It's probably more than one handler doing that, but simplified here. Then you can have one handler where you pass in runnables, and you can have another handler that passes in messages. Basically, it's always a message you pass in, but again, for simplicity here. Now, one way to use handler, and this example has a little bug in it, so we're going to look at that one a little bit more. But what we do is we create a new UI handler. We give it the looper, and we give it a callback, which will be implemented by this activity. And with the swipe refresh layout, so you swipe refresh, and you want to implement your timeout here in the UI because you don't trust the network thing you have. So the perform network sync that will be called when you call on refresh looks like this. So we have again we have a method called sync network data. We give it a callback. Whatever it does there, we don't know, but it will fetch data on the background thread. And once it's done, it called on data and give us a list of that data. What we do then, we take the data, we pass it on to the UI thread, saying here's the data. And also, we remove, we call remove message on the message timeout, because what we did first on the swipe refresh layout was show that one, and then schedule a message to happen after a certain timeout. The callback will look like this. We will have two types of messages, the timeout one and the one for the products that's updated. So if the timeout one happens, it will show you a snack bar saying, hey, network timeout, it failed. But if we get the message product updated, it will just update that one. And so the remove message will basically just remove the one that we have scheduled because it haven't executed yet. Now, if you look at this one, you see that it's still here. It might have been started running, this one, the empty message we sent for the timeout, that because here we're running on a worker thread. So this one could still show up the snack bar and load the new data. So it's still very complicated. Canceling with a handler, there's a bunch of methods you can use for this. So you can either cancel a message, give it the ID of that type of message, it will remove all of those. You can cancel a message with a specific set of objects you passed into that message, and it will remove that one. And then remove callbacks, you give the runnable that you had passed in when you call post, and it will remove that one. If you want to remove everything that is in a message queue, you call remove callbacks and messages with a null, and it will remove everything for you there. Handler it's a message-based async utility basically. It just works towards your looper and your message queue, and it's nice to know how it works. Sometimes it can be useful, and depending on what you do. My most common use case how I use this is for processing like camera frames from the camera. I create a new handler thread, and I post the frames into that one and process them, and then I post them back on the main thread. That works quite well. It's thread safe, so you can call post or send message from whatever thread you want. It's reusable as opposed to the thread class and the async task class. And you can cancel a scheduled message, but there's no built-in support for cancel something that's, has started running. So once a handle message is called for that message, you will need to check that yourself. You will manually need to add some flag somewhere. It's mostly useful, as I said, I do it for processing camera frames, and that type of processing handler is very useful for. Async task is probably one of the most misunderstood and underappreciated classes in Android. Everybody, it's just bad, it leaks references, and it's like, don't use it. Let's look at how it looks internally. So you know that you have the on-post execute where you get the result. And the way the result is delivered is using a handler. It uses that internally. So it gets a handler, it obtains a message from that for that handler, puts the result into that message, and posts it off to that handler. The handler itself is a singleton, so all async tasks share the same handler. The handler is an internal handler which runs on the main loop. It takes care of two types of messages, post result and post progress. And when you get post result, it's called finish on this one with the data that is the result. Now, here is where it actually does more than what the handler did. I said that it managed to handle cancellation that has happened once it actually started running. So it checks in the finish method, which will be running on your main thread, if it has been canceled at that point. And in that case, it calls on cancel instead. Otherwise, on post execute with the data. The cancel method, it has a flag, mCancel, you set it to true there. So that's the difference between the handlers. So if you have short-lived methods and stuff like short-lived async operations, async task is great. But there are things to remember here. So typical case here, we want to do some background work. So here I'll just fake it by sleeping for 5 seconds. And in on-post execute, I update the view with that data. And then you might also want to do something if you got canceled. But I advise you not to do anything in on-canceled, because this will be called, you probably will cancel your async task in on-destroy or on-pause or on-stop. And in that case, you don't want to update the UI. So keep that in mind. Now, a nice thing with a sync task is it has progress. Progress is also, usually all examples have been like a progress bar, so you pass an integer in there, but you can pass any type of object there. So for instance, if you have an async task that will do like a transaction, online transaction of some kind, you can just define enums for that one and pass in those enums instead. So it can be very, very useful class for these types of things, that where you do something that is still connected to the UI, but and you want to like move from one state to the next. It can only be started once. It can't be reused. So if that is a problem, you shouldn't like load a lot of data when you construct these. Callbacks happen on the main thread, so you don't have to worry about that. And you should avoid touching the UI and on-cancelled. Now, the biggest problem and the reason why people are so afraid of using a sync task is because when you define it as an anonymous inner class or a non-static inner class, you will leak a reference to the activity or fragment or whatever you defined it. So that you need to remember that one to keep the lifetime for a sync task very short. Because if it runs a long time, even if you do cancel so that on post execute is never executed, you will still keep that reference to the activity in memory. And then you might run out of memory if your activity holds too much data. So only for short-lived calls, like a few seconds. Loaders is another thing that is very misunderstood, but it's also a very complicated thing. So just going through this one fast, loaders are not asynchronous or multi-threaded by default. It's only the async task loader and the cursor loader that is that in the API. So if you want to do some loading of the main thread, you extend the sync task loader. And here is the problem where I say, like, you need to start something. The loader is very weird when it comes to starting loading. It has an on start loading callback, and there you have to check if you already have loaded data or not. So this one is usually the place where people make mistakes or forget, I cached the data and stuff like that. You have a load in background, which the sync task loader will call on the background thread. And here, you just return the data. You load the data and return it. And then you also have to implement the deliver result. And this is where you cache data. So it is a little bit much. If you need to implement your own async task loader, it's a little bit of work. So it can be a little bit heavy to work with. It's not multi-threaded by default. It's just a sync task loader, which is multi-threaded. It has a strange starting behavior. But the main advantage of loaders is that it can maintain the data between config changes. That can be nice. The recommendation is not to use this for network calls. So network calls, first you have like maybe the short-lived ones that is a transactional, online transaction of some sort. A sync task is probably useful for that one if it's okay to cancel it. If you're going to synchronize data online, like a large chunk of data, you could download your whole product, list of products, or whatever it is you have in your app. The intent service is great for that one. So intent service, you probably use this one time or another. It has the only method you have to worry about is the on-handle intent, which will run on a background thread. And here we can do everything like all the IO operations we want, no worries. And so this one is, you've probably all written something like this before. The nice thing with the intent service is that it automatically stops the service once on-handle intent returns. And the way it does that is it's in the onStart method for a service, you get a start ID. This one is passed, again, to a handler together with the intent. So when the handle message for this handler is called, which runs on a background thread, it will first call handle on handle intent with the intent that it passed in, and then it calls stop self with this start ID that onStart method got called with. And the reason this is nice is because you can start 3 instances, call start service 3 times in a row quickly, and it will just queue up these messages. And thanks to how stop self with an argument here works, the service won't be shut down until the last message has been processed. So it's a very nice utility to work. Now remember, it's a single queue. So if you think that I'm going to define 5 different intents for loading my data in the background, and then you pass in this 5 times, it will just do them serialized. So you might consider, like, if there is a huge amount of data you need to synchronize, you might want to either define multiple intent services or a different strategy for this one. It's good for long-running background calls, and I don't mean like a music player or something like that. I mean for loading loads of data, a lot of it. You can do callbacks in an intent service. I'm not going to show it here because I'm running out of time. It's complicated, so you should avoid that one. The class is called result receiver if you want to check it out. This is most useful for fire and forget tasks. So, and one thing to remember, you can't cancel it. So, yeah, RxJava is great. I love it. And as we learned yesterday, it's version 2 is coming. It's even better. I love it. I use it a lot. But all these things you still have to think about. Like you have to remember to cancel or dispose, as it's called now. Cancel your subscription properly and keep track of that one. You still need to tell which thread you want your callback on, your subscription callbacks on. So there's all these to think of still. It's the main advantage that I see when it comes to asynchronous operations with RxJava is that you use a concise, you use the same thing, you can use it everywhere in your application. It works the same way, so it's easier to read. You get one single way of doing things. So you don't have to use one loader there, and an intent service there, and an async task there. That's nice. Okay, I'm finishing off here. I want to just mention the support annotations. So if you haven't seen these before, you got the main thread, you got the worker thread, and you got the any thread annotations. These have no runtime effect, of course, but they will help you a lot in your application code if you put this on every method in your to indicate what thread from what thread can I call this one. Super useful. Any thread, basically, is what it says. So that one might be new to you. Okay, sum it up. 4 simple rules plus 1. Do not reinvent the wheel. I see it so many times. Please avoid it. Remember which of these utilities you want to use at different times. If you feel very comfortable and confident in using RxJava, you should do that. The threshold for starting to use RxJava, I've noticed, is quite high. People have a problem like getting into it. It takes a little while. So you remember the kitten? Be the kitten here. And the reason I mean like be the kitten is like cats play a lot and they make funny mistakes and it looks really cute. But they do this in order to learn. So start using these things, experiment with them, especially the handler class and using that one in a different way. Try it out, get comfortable with them, because by doing that, you will feel more safe with your asynchronous and multi-threaded and concurrency and all of those things. That was what I had to say. Thank you very much.